Hello, welcome to my PSpice channel, PSpice Tips. I'm going to show how it is possible to define an inductor with parasitics. For that, I'm going to click on Place, PSpice Component, Modeling Application, Passives, and Inductor. You have here many fields you have to complete: tolerance, initial conditions, etc. Previously, in another versions, you had to define yourself the whole sub-circuit and then define the symbol. Right now, it's possible to do it using this new application. I would like to define this component, and for that, I'm going to define here the different values. I'm going to take, for example, es 270 als Toleranz 5%. Initial condition, as here the description says, it is the current through the inductor terminals at time t equal 0. It's very important, these values, not only for the inductor, also for the capacitor, because it allows to avoid convergence warnings, okay, or problems. That's why in this case we can say nothing here, so by default is 0. So then we have here the parasitic resistive, the series resistance, that is 1.30. Als resonance frequency we have here 400 mega, so we write here 400 meg. And then, well, we don't have information for the temperature coefficients and current coefficients of the inductor. If you have it, just define it, the same as if you have a parallel resistor. In the PDF in the sheet that I showed, is not specified. That's why I clicked on Place. I have here my component, I save, and now let me make a simulation. So I'm going to make in the frequency a simulation where we say I want to start from 319 until 410 megahertz. I save and I simulate. I'm going to show, clicking on trace, first of all, the current in this circuit. We can see here, let me make this place a little bit bigger. That's how the current through the inductor varies, taking into account the frequency. We can see that there is a point here where the current is almost 0. We will see why. I'm going to click on plot, add plot to window, and what I want to show here right now is the impedance, how varies the impedance of the inductor, taking into account the frequency. For that, I say the voltage in my inductor divided through the current, and we can see, first of all, I'm going to click here in plot and synchronize x-axis, because now I'm going to make just here a zoom, and we can see here that in this point, actually this point is the maximum, is approximately by 400 megahertz. That is the point where we had the self resonance. We can see that we are in the minimum current because we have the maximum impedance, and we can see how the impedance in this inductor varies taking into account the frequency. I hope it helps for you in the future, and see you in my next videos. Thank you, bye bye.